Yeah, good afternoon, students. Welcome back to Botany first year's class. Yesterday, we have started with the VSQs from the different chapters. So that is from the ecology. From the last, we started because that is the easiest one. And damn sure we will get one VSQ from that chapter. So we will start like that only. We'll continue from those chapters where we left yesterday. I think we left at chapter 11. Biomolecules and cell division, 10 and 11, I think. Here, yesterday, we were there. That is the cell cycle, cell division. That is the 11th chapter. Okay. So in this also, we have done maximum, but few were left out. So in this, what are the most important ones where we have to stress a lot? Those are the which of the phase of cell cycle is of the longest duration? Take out your materials, mark, so that you can able to see the question over there. Okay. So which of the phases of the cell cycle is longest duration? That is the S phase, otherwise interphase. Interphase is the having the largest duration in the cell division itself. Okay. And the next one. And this was also over yesterday. Given that the average duplication time of time in E. coli is of 20 minutes, then how much will 2 E. coli cells take to become 32 cells? So 2 cells to 32 cells. So when they are doing, how many times they will divide? That means how much time they will consume for doing this type of division. So it is a simple mitosis. From the 2 cells, we need to start. 2 will become 4 over there, and 4 will become 8 over there, and 8 will become 16. 16 will become 32. That is double the number. So how many divisions? These arrows are nothing but the divisions. 20 minutes over here. Here again 20 minutes. Here again 20 minutes. And this is also of 20 minutes. That is 20 minutes. Now you can see very clearly. I have given the time with another color. 20, 20, 20, 20. That means 4 times 20. 4 into 20. That is 80 minutes. This is the answer. Okay. Like this, we have to go with this type of questions. They may ask this with the 1 cell or 2 cells. That is their vision will. But don't bug up with this type of questions. Use the intelligence over here. Need to be used that. Okay. This question is also one of the most important one. And the next one is the which of the 4 chromatids of a bivalent at interphase it is the prophase 1 of meiosis can involve in crossover. Okay, in the prophase 1 of meiosis 1, the crossing over of the chromosomes will occur. So at which chromosomes will do this? Okay, so non-sister chromatids of homologous chromosomes of a bivalent are involved in crossing over. Non-sister chromatids. Non-sister chromatids means first of all, when a chromosome divides vertically, the arms of the chromosomes were divided till the centromere, and the centromere will be the same one. Then we'll be having 2 arms at each pole. These are the chromatids. Okay, non-sister chromatids, that is another chromosome. Another chromosome having another color. If that will be crossover, this is called as the non-sister chromatids. Okay, so what he was saying, the non-sister chromatids of homologous chromosomes, those are looking alike. Okay, one chromosome is having one pair, so that is two. When the two are there, both are having the same type of structure, that is non-sister chromatids of the homologous chromosomes of a bivalent are involved in the crossing over, not the sister chromatids. So we should be very much clear with this sister chromatids and the non-sister chromatids. Okay. And the next question is, if a tissue has at a given time of 1024 cells, how many cycles of mitosis had the original parental cell will undergone? That means how many times they will do the division. Here we are going to say. So here 10 cycles, that is the, how many cells are there? That is the 1024 he was saying. In the 1024, to make from one cell, how many divisions it occurs? So that is the one what here we are saying. I am saying you to go with this. Why? Because they may end up with this question at 128 cells, 256, 512. Usually they won't say what is there in the question. Okay, they have asked about the 1024 cells, but sometimes they may ask whether if the tissue is having 512 cells, then how many divisions will take place from one cell to 512 cells? That is 9 times it will go with the mitotic divisions, otherwise 9 cycles what we have to say. Okay, so that is one cell will become 2 by mitosis, and 2 to 4, 4 to 6, 6 to 8, 6 to 12, sorry. Wait. 4 to 8, 8 to 16, 16 to 32, 32 to 64, 64 to 128, 128 to 256, 256 to 512, 512 to 1024. Okay. So whenever like this is there, they may end up till here or till here. So how many cycles are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is okay, 7, 8, 9, 10. 10 times to become 1024. Okay. So like that, they will, if they ask till 512, that is the 9, 256, 8. If they are asking that 2048 cells, then that is the 11 cycles will occur. They may change this last number. Remember this. Okay. So don't say that like the same question what we are having in the material we didn't have. In this one, they will change at any cost. So you cannot predict that same question will be going to come to us. Okay. Next one. An anther is having the 1200 pollen grains. How many pollen mother cells must have been there to produce them? So 1200 pollen grains are there. Yesterday also I said, if those who missed yesterday's class, they can easily go. Otherwise, yesterday you heard. Again, if you practice today, nothing will be harmful for you. Okay. So here, one microspore mother cell will produces 4 haploid daughter cells. And he's asking how many microspore mother cells when they are producing 1200 pollen grains. That means 1200 by 4 also you can say 1200 into 1 by 4. Then we get 1200 by 4, that is 300. 4 3s are 12, 0, 0. 300 microspore mother cells. Okay, why I am solving? Here, they will change the number of the pollen grains. They won't make the same question to be repeated. They will change the numericals. So whatever may be the pollen grains, those are the released ones, isn't it? So from the mother cells means how many times it will divide and how many mother cells. That can be done with this type of calculation. So whatever may be the number, if you know the process, we can easily go with the calculation wise. So I'm showing that calculation. Okay. Now comes the next question. At what stage of a cell does the DNA synthesis occurs? That is the S phase, where the DNA synthesis occurs. Okay. And the next one. Next one, we don't have that much of important VSQs. Now we can move to the another chapter. That is the 10th chapter, biomolecules. In the biomolecules, we will be having the important questions. Nearly 1, 2. These are the marked ones are the important mark. 3, zwitter ion, 4, 5, 6, nucleoside and nucleotide. 7. Okay. These are the most important questions. So in this, what is the first question? Medicines are either man-made or synthetic. That is, some are artificial and some are the one and are obtained from the living organisms. That is, the naturally occurring medicines will be there, and some will be the medicines which we are making artificially. So that is the synthetic medicines. Okay. So these naturally obtained ones from the plants, bacteria, animals, etc. Hence, these are called as the natural products. Sometimes natural products are chemically altered by man to reduce the toxicity or the side effects. This is the nothing but the just an introduction how we are making the medicines. With this, we don't have any further work actually. Right against each of the following, whether they are initially obtained as a natural product, otherwise a synthetic chemical. That much only we need to go now. Here, we are having penicillin, vitamin C, sulfonamide, and the growth hormone. In this, which one is the naturally occurring and which is the one what we are making in the chemical labs? That is the synthetic ones. So penicillin is going to be occurred naturally. Okay, it's a natural. Sulfonamide, it's made by the man, that is the synthetic. The first one, penicillin, is natural. It is naturally occurring antibiotic. And the next one is the sulfonamide. This we made in the lab, that is the artificial, otherwise synthetic. Okay, and the next one, vitamin C. Vitamin C, nowadays everyone knows about this, isn't it? Because In the COVID season, we used to hear that we have to improve our immunity, vitamin C, vitamin C, vitamin C, by eating this, by eating that, we'll get vitamin C. So 3 years, in 3 years, everyone knows this. Before that, we need to inject in them that vitamin C is coming by these fruits and the vegetables. Now, everyone can say, even the small kid can say from which vegetable, otherwise from which fruit we'll get more vitamin C, because that's the need, isn't it? But what we have to, how we will learn with the need only, we'll learn many things. So no need to say that vitamin C is a naturally occurring vitamin as well as naturally present in almost all fruits and the vegetables. So it's a natural product, isn't it? No need for any such conclusion or explanation with the vitamin C for you. Next one is the growth hormone. Growth hormone is also natural. How? When we are growing, are anyone injecting into our body the growth hormones? No, we are growing according to our gene. The gene is the natural one. We are not putting in our body the artificial, otherwise somewhere else, isn't it? So this is also a naturally occurring hormone. Natural. That's it. If you use the brain also, you will get these answers. If you don't know that, then just mug up. I cannot do anything like that. So usually I won't suggest the students to go with the mug up. Okay. So I'm giving you the easy tips to remember, so that everyone will be blessed with some memory. Okay, that's the God's gift. Otherwise, with the family, we will get this memory power. So I won't say that all are, and some only few are the having the good memory and all others are the dumb. No, by the situation, and the situation needs from us, then we will show our intelligence levels, otherwise our memory capacity. Till that, no, not all will exhibit their characters. Okay, so here we have to prove ourselves that yes, this is our stamina, our capacity. Then only everyone will remember you, as well as they will believe you. Okay, so to get that, you need to prove yourself with your memory. When you can able to remember your friend's mobile numbers, which is having 10 digits, 10 different numbers, otherwise 20 different numbers, why can't you remember this much of the smallest things? So no one are not buddhos, isn't it? So use the same intelligence over here to memorize the things and try to remember in a logical manner. How we will remember our friend's mobile number in a logical manner? Same like this here also. You have to implement the logical methods to get the concept and to remember the things for a long period of time. Once you start doing this, after that, no need for you to struggle. Okay, that's from my side. I can say, once you start doing to remember the things and recollect the things in a proper way, after that, no need to struggle. You will always, the brain will always be adjusted to that streamline. It will remember the things and the memory power will enhance, just like our smartphones. What is our smartphone feature? Memory can double, isn't it? 64 GB can be increased to 128 GB. If you use it in a proper way, if you keep on using, isn't it? Same thing for us also, because we only made that smartphone. God never made this. God made us, and we made all these things because we want a luxurious life. So use the same brain for ourselves. Okay. So the next question is, select an appropriate chemical bond among the ester bond, glycosidic bond, peptide bond, hydrogen bond and right against each of the following. Here also they have given four things, four options for us. So what is the one? Polysaccharide, protein, fat, water. Okay. The first one is polysaccharide. Okay. Second one is protein. Third one is fat. Fourth one is water. So here polysaccharide. Polysaccharide is having a glycosidic bond. How can we remember this? There is a logic again. So where these polysaccharides are present? Polysaccharides are present at the, if you remember the second chapter. Okay, second chapter, third chapter, fourth chapter. Plant kingdom only, we can come back. So in the fourth chapter, what we are having, a plant kingdom classification is there now. Algae, that is the fungi. Next one is the bryophyta, thallophyta, bryophyta, pteridophyta, angiosperms, and the gymnosperms. So in that, the first one is the algae, red algae, brown algae, green algae we are having. In that algal members, the brown algae is having a polysaccharide chain. That is a mucous membrane outside. The cell wall is made up of a polysaccharide, what we will say. When I have given you the differences between the red algae and the brown algae, at that time I used this polysaccharide. So try to recollect. If you are not recollecting, otherwise that means you have missed those classes. Just go back to those classes and have a look. Okay, because all are there in the YouTube, the recorded ones. So you can have a look of those questions and you can easily get back the concepts. In my subject, each and every chapter is having a link here from the first year to the second year topics. So it's easy for us to remember and connect the topics because plants are only one. There is no such occurrence, only the difference, but not the basic features. When basic features are same, all the chapters are linked ones only. We cannot say this chapter is different, this chapter is different. How can we say all are autotrophic plants? And the link should be there. Link is there, should be there, and it will be there forever. Forever in my subject, all the chapters are having the link because all plants are autotrophic, not like us. Because once we are kids, we will depend completely on the parents. Once we came to that 9th, 10th, that is 14, 15, 16, 17 years, then we feel that we're proud to be there. We are of 16 years and we can do anything, but we don't know anything. That's a different one. Again, they will correct us. They keep on correcting us now. And again, after that, once you settle in the 17 years, that is after the inter, your entire intelligence, veins, and that memory will come to the streamline. Whatever you have done the mistakes, you never repeat after that age. Why? Brain comes to the normal, starts functioning in a normal way. Okay. So here also same thing. Everything is perfect, bindas. So be sure polysaccharide is the cell wall composition in the algal members. So algal members, cell wall composition, always it's a glycosidic bond. Remember glycosidic bond. Okay. And the next one is the protein. Now comes the protein. In the protein, which type of bond? We are learning this in the chemistry. Combined with the chemistry, peptide bonds, proteins are nothing but the phosphate. Phosphate to phosphate, about which type of bond? Peptide bond. Easy or not? Easy. Don't say that, ma'am, you have done, you have finished, so it is easy for you, and we are learning, it's a hectic. Nothing is there. When we learn, we are having the much more complex questions. Now we have made everything easy for you. Okay, because you cannot eat, you have to swallow. You're addicted to swallow the things. So we made it very easy. So protein bond is nothing but the peptide bond. Okay, next one is the fat. Fat is another composition. That means the complex structure of protein and amino acid is nothing but the fat. What we know in my subject, if you don't know in my subject, in the chemistry also we know this one now. So use that. And now what could be the bond over here? Here it's the ester bond. Okay, it's the ester bond. Fats are the ester bonds. Okay, next one is the water. Water is always having the hydrogen bonds. No need to see anywhere, isn't it? Like this, we have to come to the conclusion of this resecues. Very easy in this chapter, but you have to use your brain and memory. That's it. Now, the next question. Give one example for each of amino acids, sugars, nucleotides, and fats. Okay, fats, otherwise the fatty acids, anything. Okay, so here we have to give the metabolite, that is the stored food material, in which form plants are storing in them. That's the one what they are asking over here. Okay, in the 12th chapter, where the anatomy, what we learned, secondary growth, the secondary metabolites, there is the rubber, para rubber, everything comes over here. Okay, amino acid. The best example for the amino acid is the glycine. Question is amino acid. Okay, so the best example for the amino acid in any organism is the glycine. Okay, that is the one sort of the chemical compound that is present in our body. Next one is the sugar. Sugar is stored in which form? Glucose. We know this now. Okay. Next one, nucleotides. Next one is nucleotides. Nucleotides, where we will see only in the genetic material, that is adenylic acid, guanylic acid. Okay, otherwise thymine, like anything. Okay, adenine, guanine, thymine, cytosine, uracil. We learned that as the nitrogen bases now, which are having the peptide bonds, that is the nucleotide along with the phosphates. That's the one what we are saying over here. Okay, nucleotides are the ones adenylic acid. Okay, it's easy to write the spelling. So what I am saying is this one only, adenylic acid. How we will say, how we will pronounce the word, how we will write is the impact over here better. So adenylic acid, ADENYLIC, adenylic acid. Acid spelling we know. So easy to write, because here if the spelling goes off, then no one can give you the full marks. For your kind information, I am saying. So spellings make the word in a proper way. So learn the things in a proper way. Okay, and the last one is the fatty acids. Fatty acids, example, palmitic acid. Okay, which is a very branched fatty acid that is present in the plant body. That is the, which is having a 20 carbon, a 16 to 20 carbon. That is the palmitic acid. What we are having in the 10th chapter in this biomolecules only. These are all the ones, once we learned this type of VSQs, from this, at least one question, we can easily go with the competitive exam guys. I can give you the assurance. They will give all these things in the competitive exam. So those who wants to go for the improvement, anyway, we will write the MCET exam. In that MCET exam, again, we will have this palmitic acid, adenylenic acid, glucose, glycosidic bonds, and the glycine. All these are there. So prepare well. What I meant to say is preparation makes the much more, gives the much more impact for your future and for to gain the confidence in yourself. Okay. Once you have prepared well, then you won't bother where your seating arrangement is there. Otherwise, who is the invigilator? We don't bother. Because, and who are there in the room also, we won't bother. If we don't know the subject, then we will search for our friends, nah, isn't it? But that is the wrong method. Depending on it, like a parasite on someone is not advisable. So I won't say that depend on someone. You need to believe in your memory and believe in yourself for the going with the proper way for the preparation and execution. Without the execution, preparation, it does not matter. No one will believe. You won't execute it. Okay. And the next question is explain the Zwitter-ionic forms of an amino acid. Amino acid is having the Zwitter-ionic form. What is meant by Zwitter-ionic form? Which is having the one amino acid amino acids have the ionizable nature of NH2 group, COOH groups, amino groups, and the carboxyl groups in them. So in solutions of different pHs which are present in the structure of amino acid changes. If the different pH levels are there in the solution, then the amino acids are having different structures. The amino acid is having an amino acid is having the both anionic and the cationic forms. That is called as a Zwitter ion. The amino acid which is having the anionic and the cationic charges forms, that is called as the Zwitter ion. This is the one of the amino acid. In this, what it can do, it can change this H plus. Okay, in shift over here. And now that becomes NH3 plus. And here COO minus, here H common. So with this, it is having the positive, here it is having the negative charge. So like that, the anionic and the cationic forms of an amino acid are called as the Zwitter ion, which can be interchangeable. Okay. So this one, first of all, what we have to write over here in this structure, explain the Zwitter ionic form of an amino acid. The amino acid is having the two major bondings in them. The simple way I am saying, amino acid is having two major bonds in it. That is one is the carboxyl group COOH, and another one is the amino group, that is the NH2. And the structure of this amino acid will change according to the pH concentration of the solution. And the amino acid which can change it into the cationic and the anionic forms, that is called as the Zwitter ion. That is called as the Zwitter ion. Okay. Next comes what constituents of DNA are linked with What constituents of DNA are linked by glycosidic bond? Again, the glycosidic bond came. See, okay. So here, glycosidic bond presents between the pentose sugar and the nitrogen base. Nitrogen base and pentose sugar are bonded with glycosidic bond. Okay. Easy to remember now. Next one. Starch, glucose, glycogen, and chitin are polysaccharides found among the following. Choose one appropriate and write against each. Okay. So here they have given four questions in that. Which one is the starch? Which one is the glucose? Which one is the glycogen? That's the one what we have to say. Cotton fibers. Cotton fibers are having which type of bond in them? Cotton fibers are having cellulosic bonds. Cotton fibers are having cellulosic bonds. Okay, next one. Exoskeleton of cockroach. That is nothing but the chitin. Exoskeleton of cockroach is chitin. Next one, liver, glycogen. Liver is glycogen. And next one is the peeled potato. Potato, we know it is filled up with the starch. So that is the starch. Peeled potato. Starch is the one. Like this, we have to write the answer. Okay. And the next one. What is the difference between the nucleoside? What is the difference between the nucleoside and the one? Not moving. What is the difference between nucleoside and the nucleotide? So the difference between the nucleoside, that means here we have to say how it was made. Nucleoside. When we are saying the nucleoside, nucleoside is made up of nitrogen bases. Nitrogen bases which are bonded with the pentose sugar. Those are the nucleosides. Now comes the nucleotide. Nucleotide. Nucleotide means when the nitrogen bases bonds with pentose sugar and phosphate group. That is called as nucleotide. So, if you write this much, you will get 2 marks. Very easy. Next one is the 9th chapter. That is the cell, unit of life. So in this, what are the most important questions? So what does S refer in 70S and the 80S ribosomes? What is S meant by over there? So S stands for sedimentation coefficient. Sedimentation coefficient. Okay. So which is expressed in Swedberg units. Swedberg units are Swedberg. Okay. So if you write this much, you will get 2 marks. And the next one, mention a single membrane bound organelle which is rich in R. What mention a single membrane bound organelle which is rich in hydrolytic enzymes. Hydrolytic enzymes are the ones where they are present more in the lysozymes. Lysosomes. In the lysosomes, the hydrolytic enzymes are more, which are meant with the digestion process. Okay. If you write this much, sufficient. Now, the next one is the what is referred to as a satellite chromosome. Okay, satellite chromosome means the chromosome with a round terminal beyond the secondary construction is called as the satellite chromosome. See here, this is the centromere of the chromosome, which is dividing the chromosome into 2 equal parts, right? After that, we will be having one more constriction over here. Okay, this is the first centromere. Okay, in this is secondary constriction that occurs. Pressing constriction means if this is the complete chromosome, constriction means when we are pressing in the center to leave it as the 2 arms. This is the constriction, what we'll say. Okay, so like that here, the first one, that is the centromere, what we'll call. So the chromosome which is having a small round terminal away from the primary constriction, otherwise the centromere, by the formation of the secondary constriction is called as the satellite chromosome. This is called as satellite chromosome. Now here for the chromosome, I have written the abbreviation, not the full form. Okay, but you need to write full form in the exams. You should not end up like this, right? That is the secondary constriction makes the satellite chromosome, which is a small part that is present in the at one end of the chromosome. Only at one end. Okay. Microbodies. What are microbodies? What do they contain? Microbodies. Microbodies are the single membrane cell organelles which are present in the plant cell are called as the microbodies. And these microbodies includes peroxisomes and the glyoxisomes. Microbodies are of, microbodies means single membrane bound cell organelles are of peroxisomes and glyoxisomes. So peroxisomes, what they will do? Peroxisomes And these contain the phospholipid synthesis, glycosylate cycle, and the fat metabolism. That means they can digest the fat very easily. Okay, so these microbodies can do the synthesis of the phospholipids, glyoxylates, and helpful in the glyoxylate cycle and the fat metabolism. That means fats can be utilized by the body. That is the one what the microbodies will do. And the next one is, what is middle lamellum made up of? What is its function during the, what is its functional significance? Middle lamellum functional significance. Middle lamellum is made up of calcium and the magnesium pectates. Middle lamellum is made up of calcium and magnesium pectates. See how I have written what I said. Calcium. The symbol is also sufficient over here. No need to write the full word. Ca, Mg pectates are responsible for making the middle lamellum. And what is the functional significance? It binds the two cells to form a tissue. Okay, it binds the two cells to form a tissue. Sufficient. Next one is, what is osmosis? Movement of water molecules from the higher concentration to the lower concentration by diffusion method through a semi-permeable membrane is called as the osmosis. Next one. Which part of the bacterial cell is targeted in Gram staining? Cell wall. That's it. Over these, we won't get. Next, I think we have discussed this. Yeah, 8th chapter, we have already discussed the VSQs taxonomy. From this 8, out of these 8, 1 is mandatory. Prepare well with this chapter. Like that, few chapters we are having where the VSQs mandatory from those chapters. That is the 13, 11, 10, 9, 8. Damn sure. That means 9, 10, 11, 13. 4 chapters, damn sure we will get the questions. Okay. 8 also, 5. So 5 chapters means 5 2s are 10 beta. 10 marks anyway you got it from here only. The next 10 also very easy for us to get, isn't it? And here already we have seen all these questions. So we'll move to the next chapter. Sixth chapter, we can expect the question. Okay. In that also, only few questions are the important ones. How do liver rods reproduce? How do liver rods reproduce? By spores vegetatively. Gamecups. Gamecup formation. Okay. Next one, wait. This they make you cannot give, I'm not sure. But this match the following is important, and this is important, this is important. So, which of the following are the monoecious and the dioecious organisms? That is, the which are having the both the sex organs on them, and how many are having the unisexual organisms? Okay. So the date palm, coconut, Khara, Markantia. In this, the date palm and the Markantia both are having the dioecious nature. That means the thallus, the plant body is different. The male plant body is different, female plant body is different. That is called as the dioecious nature. And the monoecious, both the sex organs are present on the same plant body. That is the coconut and Khara. Okay, and the next one is the match the followings. In this bryophyllum, agave, potato, water hyacinth, Khara, mentha. And in the second one, offset eyes, leaf buds, fragmentation, sucker, bulbil. So agave can be going with the sucker. Okay, agave with the sucker, with the bulbil. So okay, here they are asking with the type of the vegetative propagules. Sorry, vegetative propagules. So bryophyllum is the what we can say leaf now. So that is the leaf buds. Bryophyllum is the leaf buds, and agave is the bulbil. Okay, and the next one, potato. Potato goes with the eyes, we know. Water hyacinth, offset, we know. Khara is by the fragmentation. Mentha is a sucker. Okay, and the last one, define vivipary with an example. Vivipary means when the seeds start their germination, still present in the fruit and attached to the parent plant body. Fruit is still attached to the parent plant body, and the seeds are present inside the fruit. They will start developing into a new plant. That is called as the vivipary. Example, rhizophora. If you won't give the example, the statement carries only 1 mark. Example carries 1 mark. Okay, rhizophora. And the here, what do the following parts of the flower develop into after fertilization? After fertilization, which part develops into what? What we have already discussed. Ovary develops into fruit. Stamens will wither off. Ovules into the seeds. Calyx will wither off. That is fall off. That's it. With this, we have finished the 6 chapters VSQs, and we will go with the other LAQ, that is from the anatomy. Someone has prepared the LAQs from the anatomy chapter. So I want to discuss how to draw the diagram. If you know the diagram, you can explain very easily the LAQ part also. So tomorrow we will discuss about that and how which part you have to see first also, I'll say, and stay tuned to the same channel, same time for the better results for your supply exams, otherwise for the improvement exams. Okay, right? Thank you.